was amazing. I'm grateful to be here, first of all. But then, apologies, I'm going to have to rush through a couple of things. But don't worry, you'll have good content to go home with. So there is that. So when I was younger, say 6, 7 years old, we used to get the Super Strikers magazine, which is about having football players just play football, and then they have other teams that they need to also come up against, and then they'll face a couple of challenges, and then at some point then they'll either win, they'd either lose, and then learn a couple of lessons. So this is actually the first comic book I came across, and it used to come on the weekend newspaper. So every single week on the weekend, this is what I used to look forward to. So in this particular scenario, I didn't get the issue for this for that particular weekend, which was a bummer because we were left at a cliffhanger. We didn't know if the person had scored the goal or not, what was going on. So I was really excited for this particular issue. But then when the newspaper was delivered to us, it was missing the issue. So I told my parents this. I was like, okay, this my routine is normally involved with reading the Super Strikers every morning and then telling my brothers about fake stories. So every time they're reading it, they're looking at the scenario I told them about, but then they can't find it. So that's how I got to also improve my storytelling skills. Don't tell them that though. And this particular weekend, they were like, okay, we'll find or get you one at the end of the day. I'm like 7 years old. At the end of the day is like a decade to me. Like my time is different, right? So I devised a plan to actually leave the house and go to the distribution center, which was like 2, 3 minutes away, so I could easily walk. And I walked. I rehearsed what I was supposed to say and tried to act like an adult at that time and ask for the magazine that was owed to me at that point. And the person at the reception desk was actually really nice. And she was like, oh, yeah, there's an issue that was missing, but then we were supposed to deliver it to you at the end of the day. I'm like, my time doesn't work like that. So I just need to pick up my issue right now. So the person was nice to me and they actually gave me the issue. And I went back to my routine to telling my brothers about the fake stories and all that. So that went well. So in this case, when I'm talking about APIs, the request I raised to the reception lady is actually the request that as a user or as a client in this case raises to APIs. And the response of her checking the back and seeing if there's actually an issue and checking if I should actually get the issue is a response from the particular server. So that's basically how APIs work. You raise a request and get a response. So yes, I needed answers. I could not wait the whole freaking day. So there is also that. And moving on to status codes. So generally, when you raise a request, the response you're supposed to get is in form of status codes. So there's the 5 general classes that you should get responses in, and the first digit signifies the general class, and the last 2 digits are specific information about that particular bug. So if you're getting an error code or a status code of 1, that means, okay, we got your request, we're working on it. If you get 2, that means like 201 or 200, that means we've gotten your request, and here's the result. But if you're getting 3, that means ain't nobody got time for that. We're not going to do that today, but we can send you to a place where you can get your request fulfilled. And if you're getting 4, as a server, my response to you is like, nah, you did something wrong. It's your fault. Check the syntax that you're using. And if you're getting 5, then that means, okay, my bad, it's me, it's not you. If you know, you know. So if you're looking at also, whenever you're trying to build your APIs, we tend to still build out and design the particular specification and then build that out before even building the front-end interface and other components. So the first reason why it's recommended to actually design and define your API first is because you get to separate your concerns. So you get to separate the backend logic and the front-end implementation, so you can easily develop decoupled components, right? And it's easier to maintain and update. And then you also get flexibility and scalability because you're able to have different teams working at different times, and then you're also able to get all the information that you need to accommodate both users, that is the existing users and the new clients you're going to have. It also improves in terms of collaboration and parallel development because the teams can work side by side without having dependencies. And then thinking about what the API is going to be or what the results and responses are going to be allows you to have a clear and concise interface because now you've thought about the response and the various formats and error messages that the user is supposed to get. If you're starting with the API first, it's also easier to get your documentation. You can easily automate this, and then you can easily add a few concepts that you want the user to know. So it makes work easier for your documentation. And also, in terms of feature proving, that means that you're able to account for to have a stable version. So regardless of whether the front end changes or you're using a different backend or there's a recent development, you can still be able to use the API regardless of that. And another thing is that you're also able to have other people join in. You could have other people also support and use your particular API to build other services to increase the user base that you have. So it's a win-win for everybody. And if you're working with APIs, the 5 common request methods that are, these are not the complete requests. There's also one I came across called pass. I haven't used it yet, but this is basically the common things that you should accept. Like the get method. So the get request method is where the request basically retrieves the data that's already existing in the server and without making any adjustments to it. So for post is where you actually add a resource to the server. And for put and patch, which is interviewers' favorite question, what the differences are between put and patch. So if you're using the put request, then you're changing the resource in its entirety. That is, if the resource has like ID, price, description, and all that, you get to change all of it. But if you're just patching, then you're just updating partial information to that. And deleting is where you get rid of the entire resource. And then in this case, we're going to be talking about REST APIs, which means is representational state transfer, which means that REST APIs, the state is actually included in the request, so the server doesn't really need to store anything as pertains to that request. And then when it comes to the OpenAPI specification, so it's a list of what needs to happen at what time. Like, what is the resource? What is the endpoint going to look like? What's the format of the responses you're supposed to get? What is the data schema you're using? What are the data objects involved and whatnot? So moving on, why I chose to use URF, I'm going to explain like 5 of this because of time, but I chose URF because of one, there is a lot of support community-wise. You can easily get on and learn because there are so many forums, there are so many tutorials out there, and it's also built for Django, so it just makes it the easier choice. Also, it handles serialization, which means that rendering and passing your data is quite easy. And then in regards to pagination and filtering, it also helps, it comes with this like out of the box, so you just need to specify the amount of fields or the amount of data the particular user is supposed to get. And there's also a lot of that party usage, and it also covers security. So in terms of views, there are different methods you could implement views. You could easily use generics or view sets. This is highly determined by the decision that your team needs to make, or rather the project specifications and also the needs of the team as well. So for me, I would go with generics if I have a simple application I want to build and if the operations are really easy to also implement. It also uses the standard conventions and you have less code because most of the time a one-liner can handle, let's say, retrieve, update, and destroy data with just one line. And then it also runs on the default behavior of how APIs should work, so it still works. Now, if you want more control, or if the application you're working on actually needs more logic implemented based on your business needs, then I'd recommend view sets because you get to customize the logic that you have You get to have the control in terms of who has access to what, and you can easily group this in roles. And then there's also reusable code as well. And you're also able to manage complex relationships in regards to whether you're having a lot of interconnections in regards to also authentication. What are you using for authentication? How are you going to group these people in particular groups? And before I go into caching, so I have code that I was supposed to demo here. Just a second. So it actually works. So the endpoint I built was on treasures. Okay. Yeah, it works. This is what we were trying to achieve. So it actually works. I didn't do I swear it works. I actually have tests here, so you could easily test it out. It's also a Docker image, and I'll share the repo in just a second. So for treasures, say we want to create a resource. So we have name, price, and description. So let's say Drew's sweater, and let's price it to say $5.66. And then description is yellow sweater. Yeah. Then post this and see if it actually, yes, it works. So when you go to the treasures list, you can actually see Drew's sweater has been updated. So the endpoint actually work. You can create, you can see the list view and whatnot. And something else about the code, it's also a Docker container, so you can easily run it and you can give me feedback, or if you also have any questions about it, then we could get into that. So caching is storing frequently accessed data in a temporary location, which means you don't necessarily need to send requests every single time to your server. And that means that your users get to get the data as fast as possible. So first things, when you're implementing caching, you need to know data volatility. So how frequent does your data change? Is it like stock prices, which is highly volatile and highly changes? And how do you even get to manage how's the traffic? Can your API manage a lot of traffic at peak times? How does it handle all the requests that come in? And also in regards to response time, how fast do you want your responses to get to your users? Is it instantaneous? Does it lag for a minute? And then also API resources are finite, so it's a little bit, you need to be able to extend these resources to fit the particular users that you have. Something that I'd like to talk about is then, if you're caching, then the next question is, how do you actually maintain the freshness of your data? So to maintain the freshness of your data, you need to have things like cache expiration dates. This is where you actually set timelines based on the data. As I mentioned, if you're having like stock price kind of data, then you need to know like at a certain time, at like say every 5 minutes, then refresh this data. And in terms of validation, there are three methods that you could actually do cache invalidation, which means mechanisms that remove or update the entries once the data changes. So one is time-based, which is basically like cache expiration. And then there's event-driven for people who love event-driven architecture. That is where you set triggers to notify the cache system when data changes occur. And then manual invalidation, where you can have an interface to actually have a person do it for you. We also have lazy loading or cache aside pattern, where the cache is only updated when the data is requested. So when the data is requested, it first gets to the cache, and then the cache sends the data to the user. And then you could also version your particular API endpoints, where if the server compares the data that it has to the data that is cached. So if the cache data is older than the server data, then it updates the cache. And then you could also have cache control headers, where you leverage cache control methods or headers like cache control max age or no cache, to instruct the caching proxies and clients on how to cache or revalidate the data. We also have conditional requests, which means implementing mechanisms like e-tags and last modified headers. So clients can include these particular headers in their request, and the server can respond with either a 304, which is a not modified status code if the data is not modified. And then you could also have background updates for those who love also cron jobs. So you could easily have set up jobs to actually refresh and update data that necessarily doesn't change every single time. And then if you're using real-time data, you could have WebSockets or server-sent events to push updates to clients immediately by bypassing the cache every time it's necessary. And then you could also monitor and measure that by implementing alerts and systems to track the health and the freshness of your particular data. The last thing, I hope I'm still on time, is the benefits of caching. So when you implement caching, there are a few things that you are actually having. You're getting improved performance because then the users are getting the data instantaneously. So it's not somebody who's like waiting for the data, because as a user, every time you click OK, you want it to be like, okay, you're done. You can go to the next thing. Because other if it takes a lot more seconds, you're complaining that it has a performance issue, right? So you also get reduced latency because then the users can easily get the data instantaneously. And then you also get the lower server load because the server is not being engaged at every single request. And then you also have enhanced scalability because once the users that have already requested the data and the data is at the cache, then you can serve new users who are using your particularly API. So I had something on implementation. So you could either do in-memory caching or database caching. So in-memory caching basically means that you store data in the server's RAM for fast retrieval. So this is how you implement this. Don't worry, I'll share the slides. You could use something like Django Redis for this. The code is updated with the file, so don't worry about that. And then we have database caching, which is basically database caching is storing frequently accessed data in the database itself for quick retrieval. And then that's how you implement that. And then we have CDN caching if you're using a CDN, which is storing the static assets and content on distributed servers for global delivery. So the last thing I'd want to look at is in terms of security. We have 4 factors, which means that we can look into authentication, authorization, and data protection, as well as API keys. So I think you've all heard of the term when people are celebrating each other and they're like, okay, say Abby is exactly who she says she is, like because they've done like a bit of boss moves or something. So that is basically what authentication is. It's actually proving who you say you are. And a few things that you could look into is on user authentication, like using tokens. You could have API keys or 2FA, which we all use. Every time somebody else logs in into your Google account, you always get, is it you? Are you sure? Is it you? So yeah, that's pretty much it. And then on authorization, it's more or less what actions can you take based on who you are, like what are you allowed to do in the system. So the next thing is on data protection in itself. You could easily do this through encryption, such as using AES, which is asymmetric block cipher, which means that the same key, the sender and the receiver have the same key to encrypt and decrypt the data. And then data masking is what happens when you're feeding your credit card information to the particular system they're using, because you don't want anybody to just have this particular data. And then there's also the actual validation, which is validating and sanitizing the user input to prevent injection attacks. We have lastly API keys, which is basically you can do this through key management by rotating the keys that are there. You could have usage limits if you have rate limiting on your API, which is highly advised so that you don't have your resources disrupted or destroyed. And then you could also have scope-based keys, which means if you have particular keys, then you have access to more functionality. So I tried my best. Any questions so far? Okay, if there are no questions, this is a QR code that has the GitHub repo. It has the slides with more information. It also has access to the code base in itself. And then I have been wanting to come here for the longest time. It only took me 3 years to actually attend this conference. I knew about it in 2020. So this is a huge moment to me, or for me in this case, regardless of whatever took place. I enjoyed coming to this conference. I have enjoyed talking to you. Hopefully, if there are any questions that come up, I'm still around the conference, so you could easily talk about that. And yes, thank you so much. And I hope you enjoy the rest of the conference.